Electric current in conductors. In this module, you will learn about electric current in conductors. You must have seen lightning in the sky. Do you know that these lightning discharges are electric currents? Electric current is the flow of electric charge. To understand the flow of electric charges, consider two spheres A and B, where A is at a higher potential than B. When these spheres are connected, the electric charges flow from the higher to the lower potential. Thus, electric current generates due to the potential difference. Electric current can be generated due to the flow of positive charges as well as negative charges. The net amount of positive charge Q plus flowing in forward direction is equal to the total number of forward-moving positive charges minus the total number of backward-moving positive charge. Similarly, it is true for net negative charge Q minus. When Q plus and Q minus move in the same direction, the net charge is equal to the difference of net positive charge and net negative charge, while when they move in opposite directions, the net charge will be equal to the sum of net positive charge and net negative charge. The net charge flowing in the forward direction is proportional to the time interval t. Therefore, the electric current through a given area of a conductor is defined as the net charge passing through that area per unit time. The SI unit of electric current is ampere. Electric current is equal to 1 ampere if 1 coulomb of charge flows in 1 second. Depending on the application, the electric current varies over a wide range, such as around 10 raised to the power 4 ampere in lightning discharge to 1 ampere in a CFL bulb. Note that the electric current of the order of 10 raised to the power minus 6 ampere is also observed in our nerves. Electric current is steady, that is, constant with time, and it may also be dependent on time. If the rate of flow of charge varies with time, the current at any instant is determined by taking the ratio of delta Q to delta T when time delta T approaches 0. You will now learn about the flow of electric charges in different materials. You know that in atoms, the constituent electrons are not free to move away from positively charged nuclei due to their close mutual bonding. Thus, the flow of charges depends on the strength of this mutual bonding. Bulk materials consist of several closely packed molecules in which the electrons remain no longer bounded with their individual nuclei. Some of these electrons are practically free to move within the material. Such materials are called conductors. Conductivity in solid conductors is due to the movement of negatively charged electrons. However, in electrolytes, the conductivity is due to the movement of both the negative and the positive charges. On the other hand, in some materials, electrons remain bound to the nuclei of their individual atoms. Therefore, these electrons are not free to move. Such materials are called insulators. At this point, it may be interesting to note that electrons in the conductor move due to the thermal motion and have a random direction. Therefore, at any instant, on an average, the number of electrons traveling in any direction is equal to the number of electrons traveling in the opposite direction. This results in zero net current in a conductor. Now, In order to generate current, you first develop an electric field by distributing positive charge on one end of the wire and negative charge on the other end. Due to this electric field, electrons accelerate towards the positive end. However, these electrons will neutralize the positive charge at the positive end and current generates for a short while only. Therefore, in order to develop continuous current, you provide a steady electric field to maintain respective charges at the ends. By convention, direction of electric current is taken as the direction of flow of the positive charge carriers, which is opposite to the flow of negative charge carriers. In this module you have learned, current through a given area of a conductor is the net charge passing through the area per unit time, and its SI unit is ampere. Electric current is said to be steady if the rate of flow of charge is independent of time. Electric charge can easily pass through conductors because they have a large number of free electrons in them. In insulators, electrons are not free to move, as they remain bounded with the nuclei of their individual atoms. By convention, direction of electric current is taken as the direction of the flow of positive charge carriers.